what if your inequality is not linear? You can still graph it and shade. So here's our inequality. Because I see this x squared, I know it's going to be a quadratic, which is a parabola, a U shape. In order to figure out where the points go on the graph, I have to use some important details that I know. I know this plus 3 is the y-intercept, so I can graph a y-intercept at 3. I know that if I use factoring, I can find the x-intercepts, or that if I use complete the square, I can get the vertex. So I'm going to sneak and do the factoring. So we need numbers that need to multiply to 3 and add to negative 4. So it would be negative 3x times negative 1x and so our factoring is x minus 1 and x minus 3. And if we look at when that's equal to 0, we can get those x-intercepts, which are at positive 1 and positive 3. So I'll graph those x-intercepts at positive 1 and positive 3. I know that the vertex falls somewhere in between them, and I'm going to graph this inequality. Notice the symbol does not have the equal to line, so I'm going to make a dashed line for my U shape. And now my two choices are, I can have the shading be inside the parabola as true coordinates to the inequality, or everything outside the parabola could be true coordinates that work in the inequality. So we can test each. If I pick a point outside the parabola, for example 0, 0, if I try 0, 0 in the original inequality, 0 is less than 0 squared minus 4 times 0 plus 3. So that gives me 3. Is 0 less than 3? Yes. So this 0, 0 or red spot is true, and so all the spots that are outside the parabola can also be shaded. Anything inside the parabola is a coordinate that would make the inequality false. We have a couple other examples. Our next equation is not a quadratic because the x isn't squared, but the x is in the exponent. This is called exponential or exponential growth. The 4 is the starting point, the y-intercept, and the 1.15 is the multiplier. Because this multiplier number is greater than 1, this is going to be a growth, and it's growing by 15%. So I'm going to put a y-intercept at 4 and just sketch an exponential growth graph. Again, noticing that it is strictly less than, not equal to, so I'm going to make a dotted line, kind of showing my exponential growth. Doesn't have to be very exact. And then we need to decide, should it be shaded here, kind of above or inside the exponential growth, or outside or on the bottom of the exponential growth. So we can pick a coordinate like, I always pick 0, 0. Let's pick something different. We will pick 1, 1. So if we try 1, 1, is 1 less than 4 times 1.15 to the 1 power. And if we do 4 times 1.5, that's a number that's bigger than 1, so yes, that's true. So the shading should be all coordinates on this lower, kind of outside of the exponential growth, would be coordinates that are true and work in this inequality. In part B, we see another squared. This is a quadratic that's in a quadratic in vertex form. So the here and here are telling me the vertex, and we would say that the vertex is at positive 6, 3/4. So I can graph that. 1, 2, 3, 4, 5, 6, and 3/4. Here's kind of the coordinate of my vertex. Because this 1/4 is here, that's positive, so that's telling me that my parabola is going to be opening upwards. And the 1/4 makes it a little flatter than a normal parabola. Oh, and it's a solid equal to, so I can make a solid equal to. I don't have to be very exact. And then I can pick any coordinate to test either inside or outside of the parabola. I'll pick 0, 0. Is 0 greater than or equal to 1/4 times 0 minus 6 squared plus 3/4? Okay. 0 minus 6 squared is my first step with order of operations. So that would give me 36. So I have to do a fourth of 36, and then plus 3/4. Fourth of 36 is 9, plus 3/4 is 9 and 3/4, and that is not smaller than 0. 0 is not greater than 9 and 3/4, so that is no. So 0, 0 is the wrong spot to shade. All this should stay open, and we're going to shade inside the parabola as coordinates that work in the inequality and make the inequality true. Last example is a absolute value. I would say for right now, you should just have memorized that an absolute value graph is a V shape, and that you might need to build a table to help you figure out what this graph looks like. -2, -1, 0, 1, 2, and try plugging in some numbers to get the graph. I'll draw it in quickly because I have it memorized. Because we have a strictly less than, we're going to have a dashed line for our V-shaped absolute value, and then we're going to try to shade inside or outside the absolute value. Let's try this coordinate, which is 0, 5. 0 is less than absolute value 2. Oh, I have that backwards. The x-coordinate is 0 and the y-coordinate is 5, so we have 5. 2 times 0 minus 1. So that would give us the absolute value of -1, which is +1. And we're wondering, is 5 less than 1? No. So inside the absolute value is wrong. We won't shade that, and we will instead shade or highlight all coordinates outside of this V shape are coordinates that would make this inequality true.